So we're given that in a class of 40 students, 19 play tennis, 20 play netball, and 8 play neither of these sports. A student is chosen randomly from the class to determine the probability of each of these events. Now, we'll set up our Venn diagram first of all. And we're told that there are 40 students in the class and that 8 play neither of these sports. So if we're going to set up our Venn diagram, the first thing we can fill in is our null set. We know that 8 students are not going to play either sport, so they're not going to either play tennis or netball. Now, we're not really too sure the breakdown of how many students play both, but we can use a calculation here. And so what we can say is we'll let X represent the number of students that play both. Well, if 19 play tennis, well then 19 minus X play only tennis. And if 20 play netball, well then 20 minus X will be the number that play only netball. And now we can just find out what X is, because now we can use a formula here. We know that 32 is equal to, and it's going to be the number that play tennis plus, or just tennis, plus the number that play just netball plus the number that play both. And when we simplify this, it's going to be, if we rearrange the equation here, it's going to be 39 minus X, and that's this side simplified because negative X plus X is negative X, and 19 plus 20 is 39, and that's equal to 32. So now what we can do is just subtract 39 from both sides, and you get negative X is equal to, so negative X is equal to negative 7, so X is equal to 7. So if we sub in here, well, we know this is 7, which I'll change color just so it stands out a bit more. We know that the number that play both is 7. And we know then that 13 must play just netball and 12 just play tennis. And if we add this up, this would be 19 plus 13 is 32. So we know that we've got that right, because recall that 8 play neither, so that'll give us a grand total of 40 students. So based on this, the probability that a randomly selected student plays tennis in the class is going to be 19 out of the 40. Because 19 is the number of students that play tennis, and our sample set is 40. Probability that the student does not play netball, well, 20 students in the class play netball, that means 20 don't play netball. So it's 20 over 40, which is 1/2. So a 50% chance of selecting a student that does not play netball. Probability that you select a student that plays at least one of these sports, well, we know that 32 students play at least one of these sports and 8 don't. So the probability is 32 out of our sample set of 40, which is then 4/5. Now, next we're asked to find the probability that a student plays one and only one of these sports. So we have to figure out how many students play only one sport. Well, 12 play only tennis and 13 play only netball. So the number of students that play only one sport is 25, and we divide that by our sample set of 40. So this is equal to 5/8. So probability that a student plays netball but not tennis. So it's only this group here that we're interested in, because 13 students out of the class, or out of this group, only play netball. And so then the probability that they play netball but not tennis is going to be 13, which represents the number of students that play netball but not tennis, over our sample set of 40. Next, we're asked to find the probability that a student plays tennis knowing that he or she plays netball. Well, we know that the sample set here is going to be the population of students that play netball, and we know that that's going to be 20, so that's going to be our sample set. And of the 20, the ones that play tennis is 7. So it'd be 7 over 20. Now, this is the important part, that you know he or she plays netball. So that means when you know that, you know you're only talking about these 20 students. And so that's going to be your sample set. And of that sample set, 7 play tennis.